right, so we've been solving systems with two variables. In other words, it has an x and a y. You can graph things in a two-dimensional plane, right? But we live in a three-dimensional world. So there's this thing called, you guys are used to seeing triples, you guys are used to seeing things like this where there's an x, comma, y. Well, that's a two-dimensional plane. But we live in a three-dimensional world, so to exist in a three-dimensional world, we add a third variable, which is z. All right, now I'm not gonna talk too much about it, but we can graph an actual plane by including an x, a y, and a z. And basically, how do I word this? We think of, well, a picture is better than me actually trying to explain it. So this is more like the world we live in, okay? So we have, you guys are used to there being an x value, right? So the green thing will be x. That's like the x values. We'll say the red thing is like the y values, right? We're used to y values. Let me put it up there. That'll be better. And then to add the depth, well, that would be your z values, okay? So the origin will be the center of some space, and then the location from the origin would be x, y, z, okay? So anyways, we're not going to graph things in three dimensions. That's not a high school level class. But the algebra part, it's a very algebra 2 thing. So to solve a system, what I'm looking for is somewhere in three-dimensional space, there exists a dot. I don't know where it is, but wherever that dot is, it has a value of x, y, z. Now, I can have an equation representing a plane, right, or a location. And anyways, what I'm trying to figure out is where do all these points actually cross. So a better understanding of it would be to find the system or solution of a point. I'm trying to figure out where all three of these planes will cross, okay? In other words, what we were doing is we were thinking in terms of a two-dimensional plane, right, where we had x and we had y, and then we had two equations where there'd be one graph that went this way, and then we had a graph that went this way. And then we were interested in where they crossed, right? Those were the solution set. But now we have planes that intersect, and we're interested where all three planes intersect. That's the solution to one of these systems, okay? So let's and it's called an ordered triple, okay? So this is called an ordered triple. I just wanted to talk that the other one is called an ordered pair. This is called an ordered triple because there's three. All right, so to do this, we're going to solve these by substitution. So we're going to plug some things in, we're going to substitute some things, and we're going to try to figure out how to find the answers, all right? So one way to do this is I can solve for y and plug it into the other. So notice that this one has a y all by its lonesome. Notice that this one has a z all by its lonesome. So the first thing I'm going to do, so this is equation 1, this is equation 2. So for equation 1, I'm going to take this negative 2x plus y plus z, 3z, equals 20. What is wrong with me? And I'm going to solve for y. Okay, so these problems are somewhat rigged up for you. So I'm going to add 2x to both sides. Whatever I do on one side of the equal sign, I have to do to the other. And then I'm also going to subtract 3z. So I'm doing the opposites. I'm moving the 3z and the negative 2x away from both sides. So I'm going to subtract 3z. On this side, I'm going to get 2x minus 3z plus 20, because that's a positive 20, is equal to y, because these will cancel. So now this is still equation 1. I just kind of reorganized it. Okay? Now, for equation 2, I'm going to substitute the y in for equations 1 and 2. In other words, so this is equation 1, solve for y. Now for equation 2, equation 2 is negative 3x plus 2 times y. Okay? 2 times y. But what I'm going to do is I'm going to take equation 1, which is set equal to y, and plug that in. In other words, I'm going to plug in 2x minus 3z plus 20. And I'm going to pause right there so you can see what I'm doing. This is y. So I'm writing this equation. I'm writing out this equation, but wherever there is a y, I'm plugging in equation 1. So this is equation 2, negative 3x plus 2 times y. But instead of plugging in y, I'm plugging in equation 1, which is solve for y. So I'm plugging this in for y. So before I move further, do you guys see that? Does that make sense? Okay. Now we're going to do this multiple times. The reason we're going to do this multiple times, you'll see that every time we substitute something in, eventually the goal is get one variable. So right now I have x, y, z. Through this process, I'll end up with all x's or all y's or all z's. And then I can solve for z, and then I'm going to work back and plug in the value for z, then work back and plug in the value for x or y. And eventually I'll be able to solve for x, y, and z. All right, so I still got to finish this equation. What's the next thing I need to write down? Plus z, right? So right here I have a plus z equals 21. Now, when I do that, I'm going to have to push this 2 through the parentheses. So now I have 3x plus 2 times 2x is 4x. 2 times negative 3z is negative 6z. 2 times positive 20 is positive 40. And then that's it. And then you just put the plus z, that's a z, equals 21. Now I have some like terms here, so I can combine the negative 3x and the 4x. That's just x, right? I have a negative 6z and a positive z, so that's just negative 5z. And then lastly, I'm going to subtract 40 on this side and subtract 40 on this side. When I do that, these cancel. What's 21 minus 40? Yes. Oh. So I'm saying negative 6 plus 1z. Right? Okay. Good question. So let's do this too. Maybe I should put it on the calculator so you can see it. So what's 21 minus 40? Negative 19. Okay? So this becomes, over here, this becomes negative 19. Now notice in that little substitution, I actually eliminated the y's. So now I'm down to 2 variables. I got to do this with the third equation. So this is equation number 2. Okay, so this whole thing is equation number 2, but it's changed. Now, the hard part for me is when I did this on my own for the first time, I had a hard time. I would solve for one variable, then solve for the other variable, and not eliminate variables. Okay? It's very tempting, but you got to think, okay, well, now that I've gotten rid of the y, I need to either work on getting rid of the x or the z. That's how your mind has to work, okay? Let's do the same thing for the third equation. So if I take the third equation, and it's up here, this negative 9 thing, I'm going to write it like this. I'm just going to switch. I'm going to say negative 9 is equal to 3x minus 2, and then I'm going to substitute in for y again, plus 3z. What am I substituting in for y? Equation number 1, this stuff right here. Right? So I'm going to put in 2x minus 3z plus 20. Now the reason I'm doing that is, if you notice, now I don't have any more y's left. So I'm going to push the 2 through. This becomes a negative 4x. Going to push the 2 through here. Negative 2 times negative 3 is a positive 6z. Negative 2 times positive 20 is a negative 40. So when I push that 2 through, that's what I get. Everything else just kind of drops down. So this is still negative 9 is equal to 3x plus 3z. So then I've got my negative 9 here. I'm going to do some combining of like terms. So 3x minus 4x gives me a negative 1x. I've got a couple of z's over here too. We'll use yellow this time. I have a negative, or no, they're both positive. Positive 6z plus 3z is a positive 9z. Can you guys see the yellow okay? Okay. And then I just have this constant of negative 40, but I'm going to move that to the other side. So I'm going to add 40. So let me put green. I haven't used green yet. So I'll say plus 40 over here. And then I got to add 40 over here. Well, let me write. I'm going crazy. What did I do? I thought I wrote 9z down. Did I write it down? Did I erase it? Maybe. I'm getting ahead of myself. So then I'm going to set it right there. When I add 40 to this side, am I running out of space? Yeah, I am. This becomes, I'll have to write this over on the other side. This whole thing becomes, why is it that I can't see it? I see why. There we go. This whole thing becomes positive 31. Oops, let me do this in black. Positive 31 equals negative x plus 9z. And so that is now the new equation number 3. Okay? Yeah, that's 31. All right, so I have two equations where I have an x and then I have a z. Now I can do elimination on this, or I can substitute. So if I substitute, this is the interesting thing. If I substitute, then I just need to solve one of these for x. Notice that this one is already solved for x. So I'm going to come over here, and I'm going to say this is equation 2. I've got x minus 5z is equal to negative 19. So if I add 5z to both sides, I get x equals 5z plus, oh, not plus, minus 19. Okay? This is still equation 2. All right? Still equation 2. So now I'm going to take my new equation 3, which is 31 equals negative x, but guess what I'm going to plug in for x? I'm going to plug in the new equation 2. This is the hard part. You got to slowly, systematically eliminate all the variables. So when I plug this in here, 5z minus 19, And then I got to complete writing the rest of equation 3, which was plus 9z. Okay? So if you need to see it all, let me show you. I'm taking this line right here, and wherever there's an x, I'm plugging this in. So this equation is actually this equation, except where there's an x, I'm plugging in the modified equation 2. Now, by doing that, essentially what I've done is I've eliminated all the variables except for z. Okay? But I still have to distribute this negative sign. So what's negative? And if you don't know how to do that, think of that as negative 1. What's negative 1 times 5z? Just negative 5z. What's negative 1 times negative 19? Positive 19 plus 9z. Okay? Combine like terms. 9z minus 5z is a positive 4z. Yes?
Does it matter which equation you get like y for? You know what I mean?
No. But I will say this. It is easier. You got to look at the equations and figure out which one's easier. So systematically, I chose the first equation because it already had a y by itself. Okay? So because it had a y by itself, it's easier to solve for y. Now, I could have done the same thing with the second equation because it had a z by itself. And so once I do that, then I got to if I were to choose the second equation, then I would plug that in for the z for the other two equations. In other words, if I started with y1 and I solved, if I started with equation 1, let me back up so you can have a visual. That's a great question. The question was, does it matter which equation you use? And the technical answer is no, but there is a systematic approach to doing it. I started with equation 1. I solved equation 1. So immediately I know that I need to plug that into equation 2 and equation 3. The other two. Now, I could have solved equation 2 for z. If I did that, then I would need to plug that into 1 and 3. Does that help? Okay. And the reason for that is I'm systematically, and that's the part that's hard. Because some kids will solve equation 1 and then try to plug it back into equation 1. No bueno. Okay. So you got to choose the other two. You had your hand up too. Oh. Oh yes, you're correct. Sorry, I get distracted. All right, so yes, thank you. I'll be curious if I said 19. I'm pretty sure I said positive 19. I've been doing that a lot today. Like my brain goes faster than my hand can keep up. All right, so yeah, so remember negative 1 times negative 19 is positive 19. I forgot to write the 1 in there. So anyways, now I can solve for z. So I'm going to subtract 19 from both sides. Okay. When I do that, well, let's just do the math. So I've got 31 minus 19, 12. That's pretty easy. So I've got 12 equals 4z. Divide both sides by 4, and I get 3 equals z. Okay? So now that I know what the z value is, I can go back to either one of these modified equations over here. Let me zoom out so you can see it. Notice that both of these equations have x. Well, technically, this equation is solved for x. And now that I know what z is, can I plug the value for z in here? Yeah. So if I take equation 2, the modified one that I solved up here, I know that, and this, I'll write this down, equation 2, and this is where the practice comes in. You're going to go, well, how do I solve for the next variable? You got to find only 2 variables. This one's easy. Why did I pick this? Because it's already set equal to x. So if I want to know the x value, I plug that in. So I'm going to say the x is equal to, let me scroll up, 5z minus 19. So I'm going to say 5z minus 19, right? But z is supposed to equal 3. So I get 15 minus 19. Whoops. That's equation 2. I got that. This is the modified equation 2, right? So that is x. X is equal to, technically it's not equation 2 anymore, but I like to keep track of them. So x equals negative 4. Thank you. So then, now what do I have to solve for? Y, right? I need x, y, z. So now here's the interesting thing. I'm not going to tell you this. I want you to kind of think about that. Is there something that I can use easily to find y? Huh? No scopes? It's right there on the all the stuff I have written. Look, think, use your brain. Oh, it hurts to think. No, not Desmos. You could do this in Desmos. No, you can't. Right here. Isn't that set equal to y? Doesn't it have an x value? Doesn't it have a z value? Couldn't I plug in this and this into this equation? Still no? Well, it's not no. It's actually yes. So what I'm going to do, this is going to be the tough part, is being able to do. So I'm going to say y equals 2x. Let's see if I can do this. I got to get it just right. So I'm going to say, and this is equation 1. Y equals 2x. Oh, but I know what the value for x is, so let's just plug in the value for x. 2 times x minus 3 times z. What's z? 3. What's x? Negative 4 plus 20. So then I get y equals 2 times negative 4, which is negative 8. Negative 3 times positive 3 is negative 9 plus 20. Negative 8, negative 9 is negative 17. 20 minus 17 is 3, right? So what's my answer? Well, my answer is x, comma, y, comma, z, or x, which is negative 4, comma, y, which is 3, comma, z, which is also 3. That's the answer right there. Actually, let's do that in a different color so you know it's the answer. So we did all that work. So all three of those equations intersect at the ordered triple of negative 4, comma, negative 3, comma, or not negative 3, negative 4, comma, 3, comma, 3. Whew. Do you guys feel smarter? Now, you will have one of these on the SAT, I promise you that. And if you get this one right on the SAT, they'll be like, yay, this is a smart person. Well, I shouldn't say that. Yay, this person worked hard to learn this. This is a hard worker. There are no feelings on SAT scores. Either you're right or wrong. How you feel is irrelevant. Do or do not, as Yoda says. There is no try. Do or do not. All right. Yeah, it's not easy for sure. But with a little practice, you can get it.